Measuring matter. In this lesson, we will look at what units are used to express mass and volume, and we will also look at how we determine density. So we'll calculate density, we'll look at a number of things that sink or float, and then we'll also look at an example as to why using density was actually important. So what units are used to express mass and volume? What weighs more? A kilogram of feathers or a kilogram of sand? The answer, they weigh exactly the same. 1 kilogram of feathers equals 1 kilogram of sand. They may not occupy the same space, but 1 kilogram of feathers still equals 1 kilogram of sand. So there are a number of different ways to measure matter. As you've seen in the past, we've done a little bit of measuring of different things. We rely on measurements, and we also want to make sure that those measurements are extremely accurate. We've actually started to develop new technologies that allow us to measure more precisely. So it used to be that really the only thermometer you could use was the glass thermometer that had either mercury in it or it had some type of alcohol in it. Now we've gotten more and more complicated as far as our development of new thermometers. We can actually have thermometers that measure to the nearest thousandth of a degree. Many of those are digital thermometers. And we want to be as accurate as possible when taking measurement readings of any type. Weight. Weight is a measure of the force of gravity on any object. On any other planet, the force of gravity will be more if the planet is more massive than Earth, and it will be less if the planet is less massive than Earth. So an example of that, if you were on the moon, you would weigh 1/6 the weight that you do on Earth. So with that information in your head, if you know that you would weigh 1/6 the weight you are now on Earth on the moon, calculate your weight on the moon. Take a minute to give that a try. In order to answer this question, you would need to know the decimal number for 1/6. So I'd take 1, divide it by 6, and get my decimal point. And then I would take that number and I would multiply it by the weight that I am. And that would give me the weight that I would be on the moon. To find the weight of any object, we can place it on a scale. Some scales are digital, like the ones that we use for wrestling. The wrestlers weigh themselves on a digital scale that they just simply step on. It gives a digital readout on a display. Or you could weigh any object, kind of like on the next slide. We've got a picture of a spring scale, and that spring scale measures the weight of an object based on the pull of gravity. So the amount of movement the scale does depends on the weight of the object. So use the weight of the first scale to estimate the weight of the fish on the next two scales. So if one fish equals around 2 kilograms, maybe a little bit less, the second scale we have 3 fish on. So 2 times 3 would give us somewhere close to 6. The next picture has 1, 2, 3, 4, looks like 5 fish on it. So it would be 2 times 5 would give us somewhere in the neighborhood of 10 kilograms. It may be a little bit less, but somewhere up in the upper end of that spring scale. Mass. So how can you weigh less on the moon than on Earth if nothing about you's changed? You didn't add more or less matter to you. You're still the same amount of matter. The same amount of atoms make you up. So how can you weigh less on one body versus on another? It's because your weight is dependent on the gravity of the planet that you're on. And the amount of matter in an object is its mass. So if you travel to another planet, the amount of matter that makes you up, mass, does not change. Your mass does not change. You still have the same amount of matter making you up. Due to this, we prefer to describe matter in terms of mass rather than weight. Because if you were to go to Mars, your weight is going to be different. Your mass does not change, but your weight will. So going back, a little bit of review. If I have a baseball that has a mass of 150 grams, the mass of that object in kilograms after I have converted it is 0.15. Remember that on our metric map, kilograms is 3 places to the left of grams. So I would just simply move the decimal point 3 places to the left. Let's go down to pineapple. Give pineapple a full can of soda and an inflated balloon a try on your own. When looking at the pineapple, if it weighs 1,600 grams, I would move the decimal point 3 places to the left, which would give me 1.6 kilograms. The full can of soda 3 places to the left would give me 0.39 kilograms. And the inflated balloon 3 places to the left would be 0.003 kilograms. So a challenge for you. Suppose that you're taking a flight to Europe. You're only allowed a 23 kilogram suitcase. How much in pounds is 23 kilograms? A hint, 1 kilogram equals 2.2 pounds. Go ahead and give that a try. In order to convert this, I know that 1 kilogram equals 2.2 pounds. So on the 1 kilogram side, I'm going to multiply that by 23 because I know I have 23 kilograms. What I do to one side, I need to do to the other side. So I multiply 2.2 by 23 as well. So 23 kilograms equals 50.6 pounds. So your suitcase is allowed to be 50.6 pounds. Volume. All matter has mass and takes up space. The amount of space that matter occupies is called volume. You occupy volume. Any object occupies volume. It has a certain space that it takes up. The metric unit of volume is the cubic meter. When we're in the lab and we're measuring the liquid's volume or an irregular shaped object's volume, we use a graduated cylinder. So measuring volume. If we can calculate the volume using a graduated cylinder, that's perfectly fine. There are certain things that it becomes more difficult to use a graduated cylinder to measure its volume, unless it's a very large graduated cylinder. So if we have a regular shaped object, all we need to do is measure the volume by multiplying the length times the width times the height. So in this case I have 63.5 centimeters times 23 centimeters times 43 centimeters. Take a minute to find the answer. You should have gotten 62,801.5 centimeters cubed. Measuring irregular volume is slightly different. Sometimes we have objects that aren't a regular shape, so we can't measure length times width times height. In this case, we use a graduated cylinder. And suppose that the raspberry that's put inside of this graduated cylinder, prior to it being put inside of the cylinder, the amount of liquid was 15 milliliters. And our ending amount is 20 milliliters. In order to find the volume of the raspberry, we would want to know the difference between the starting amount and the final amount. So if I went from 15 to 20, that's a change of 5 milliliters. That tells me the raspberry must be 5 milliliters in volume. How do we determine density? So even though a pound of feathers weighs the same as a pound of sand, they do not occupy the same amount of space. The volumes differ because sand and feathers have different densities. So in order to calculate density is a measure of the mass of a material in a given volume. It can be expressed as the number of grams in 1 cubic centimeter, so grams per cubic centimeter. You can determine the density of a sample of matter by dividing its mass by its volume. So density equals mass over volume. This helps us to determine if an object would sink or float. So if you had a block of wood and a block of iron of equal mass, when you drop both blocks into a tub of water, you see that the wood floats and the iron sinks. The density of water is 1 gram per cubic centimeter. So any object with lesser densities will float, and objects with greater densities will sink. So if you watch a bottle that is filled with oil and vinegar, you notice that the substances slowly separate out. This happens because oil is less dense than vinegar. So with the information that you have, and looking at this beaker on the right hand side of the screen, we need to know what substance is which in the picture. So probably the best way to go about figuring this out is finding the substance with the lowest density. The substance with the lowest density is going to float. And it's going to float on top of all the other substances. So the lowest density is vegetable oil of 0.9 grams per milliliter. So vegetable oil is going to be on the top. Now take a minute, put the remaining in order based on their densities. The next lowest is going to be water. And then dish soap. And then corn syrup. And the greatest density is going to be honey. Therefore, it will sink below all of the rest. So, real life example of using density. So, suppose that you're a gold miner in the 1800s. One day you're panning through sediment in a stream and you come across a big chunk of shiny golden rock. You know from experience that not all rocks that are golden and shiny are actually gold. So you need to know, is this rock actually gold? So how do you figure that out? You can measure the mass and the volume of the rock in order to find its density. The density of gold is 19.3 grams per cubic centimeter. So if I find a density that is 19.3 grams per cubic centimeter, or really close to that, then I know that the rock that I have found is just gold.